Design of an isolated footing. In this video, you will understand the problem statement, and do the initial calculations, so that you can proceed with the design in the software. This is the problem statement, for design of the isolated footing. The dead load, acting on the footing center, through the column axis is 300 kN, and the live load is 140 kN. The column is a square column, of side length 500 mm. You'll have to use reinforcement bars of diameter 20 mm. The safe bearing capacity of the soil underneath is 100 kN per meter square. The materials to be used are concrete of grade M30 and reinforcement bars of grade HYSD 415. Consider the allowable settlement of the footing to be 1 cm. Now let us do the initial calculations. The area of the footing to be designed is given by total load divided by the safe bearing capacity of the soil. Total dead and live load is 300 plus 140, that is 440 kN. And the safe bearing capacity is 100 kN per meter square, as mentioned in the problem statement. So the area comes to 4.4 meters square. As we are designing an isolated square footing, so the length of each side will be root over 4.4, which is equal to 2.09 meters. This 2.09 is the minimum length of each side of the footing, so for simplicity, we will take a higher value of 2.5 meters. So you will be designing a footing which has a square column of 500 by 500 mm size in its center, and the length of each side of the square footing is 2.5 meters. Thus, from the center of the column, the distances to the left, right, top, and bottom edges will be half of 2.5 meters, that is 1.25 meters each. Now, you will calculate the subgrade modulus, which is a property of the soil. The subgrade modulus is given by the safe bearing capacity of the soil, divided by the allowable settlement. The SBC is 100 kilonewtons per meter square, and the allowable settlement is 1 centimeter. 1 centimeter is 10 to the power minus 2, in meters. Thus, the resulting subgrade modulus is 10 to the power 4 kilonewtons per meter cube. Next, you will calculate the design strip width. You will be drawing the column strip. As mentioned in the design codes, the width of the column strip, on either side of the column center line, is given by 0.25 L1 or L2, whichever is less. L1 and L2, being the footing slab dimensions, in X and Y directions, are same and equal to 2.5 meters. Thus the strip width is given by 0.25 times of 2.5 meters, which equals 0.625 meters. We are using a lesser value, of half a meter in this problem, for the sake of simplicity. As you go on to do more projects, you will be using more accurate values. So these were the primary calculations, based on which you will be designing the footing, in the next video. Thanks for watching.